Okay, 27. The following diagram shows this stuff. Find the area of the triangle. Okay, so we have, we can find out this to be 80, and then we can use sine rule to find either side, and then we can use 1/2 AB sine C. So we're going to have 105 over sine 80 equals x over sine 40. So you end up getting x is 68.5. And then you can use this, and this include angle. So 1/2 68.5 unrounded times 105 sine 60. Okay. And this ends up giving 3,120 meters squared. All right, 28, we've got ABC. A is 30. BC's 3, AB's 5. Find two possible values of B. So we've got 3 over sine 30 equals 5 over sine C. So, and we're going to have triangle 1 and 2, and 30s are given angle. Okay, so we get C is 56.4, which goes here. And we do 180 minus that thing, which is 123.6. And then we do 180 minus 30 minus the 56.4, and that gives you 93.6. And if you do 180 minus 30 minus the 123.6, you get 26.4. So those are two possible values of B, because these were both, these were C and this is B. Okay, so for 29, obtuse angle, all that information, find the area. Okay, so we're going to have 8.71 over sine 50 equals, and we can look for this side. Oh no, actually, what are we doing? We need this angle. Okay, so 10.9 over sine B, and we have 50 and 50. So we get 73.5, and 180 minus that is 106.5. And then we do 180 minus 50. Minus 73.5, and that's 56.5. And then we do 180 minus 50 minus 106.5, and that's 23.5. Oops. 23.5. Okay. So we found this is angle B, and we need angle C. Okay, so that's there. So we have 1/2 8.71 times 10.9 times sine 56.5 unrounded, and we have this same stuff and sine of the 23.5 unrounded. So for this one we get 39.6 centimeters squared. And for this one, we get 18.9 centimeters squared. So I'm just reading because it's obtuse triangle. So this has to be it, because it has to have an obtuse angle. So this is our answer. All right, and 30, we have ABC. C is 42. BC is 1.74. And we've got area 1.19. So 1/2 1.74 times AC, and then sine 42. So x ends up being 2.04, and then we need AB. So, so this is 2.04. We can use cosine rule. So we have w squared equals 1.74 squared plus 2.04 squared minus 2 times those things, cosine 42. So we get that w is 1.39. All right, 31, we've got triangle ABC. A is 30. Across from A is 5. Across from C is 7. Find the difference in area between the two possible triangles. Okay, so we have to find, we have to find this angle. Or to do the area. But first we need to find this angle, and they've told us. Okay, so we've got 5 over sine 30 equals 7 over sine C, and figure that out. So 44.4, and then 180 minus that, which is 135.6, and then 180 minus 30 minus the 44.4, which is 105.6, and 180 minus 30 minus the 135. So this is 14.4. So that gives us, so this is C, so this is B here. So we're going to have 1/2 7 times 5 times sine 105.6, and 1/2 times 7 times 5 times sine 14.4. So for this one we get 4.36, and for this one we get 16.9. So when we subtract the two, because we want the difference in areas, we get 12.5. That's the difference. All right, 32, triangle ABC. We've got, this is 30. AB is 6, and AC is 3√2. Find possible areas of the triangle. Okay, so we can find out this angle in order to find out this angle. So we're going to have 30 and 30. Then we're going to have C here, and then A here. So we're going to have 3√2 over sine 30 equals 6 over sine C. All right, so 3√2, and sine 30, this is 30, so sine 30 is 1/2. And we have 6 over sine C, so this is going to be 3, so sine C is going to be 3 over 3√2. So this is actually 1 over √2, which is √2 over 2, if we were to rationalize the denominator. Okay? So when is sine √2 over 2, we can make it here. So that's at 45 degrees. Okay? And if we do 180 minus 45 degrees, we get 135. And then that's going to be 105 because it adds to 180. And this is going to be 15 to add to 180. And then if we have 1/2 A, B, sine 105, and 1/2 A, B, sine 15. This one will be 12.3 centimeters squared, and this one will be 3.29 centimeters squared. Okay, we've got ABC. This is 30. This is 6. This is 3 root 2. Find possible lengths of BC. So we need to find this angle first. So we've got 3 root 2 over sine 30 equals 6 over sine C. Okay, 30, 30, and then C comes next, and then A. All right, so we've got 3 root 2 sine 30 is 1/2. So if we cross multiply and divide, we're going to get sine C equals 3 over 3 root 2, which is 1 over root 2, which is when you multiply by root 2 over root 2. To rationalize the denominator, you get root 2 over 2. Okay, so sine is root 2 over 2 here at 45. And 180 minus 45 is 135. And then these must add up to 180, just like last time. So for BC, we've got x over sine 105 equals 3 root 2 over sine 30. And we have x over sine 15 equals 3 root 2 over sine 30. So this one gives 8.20, and this one gives 2.20. So if we use cosine rule here, we have, let me just write in red, we have this is C, this is C, and this is A and B. So we're going to have, I guess it doesn't matter, 3 root 2 squared, C squared, equals A squared plus B squared minus 2AB cosine 30. Okay, so this is 9 times 2, 18, 36, x squared, 12x, and cosine 30 is, cosine 30 is root 3 over 2. So if we multiply through by 2, we're going to have 36, 72, 2x squared, and 12 root 3x. And then get it equal to 0, because it is quadratic. And that's going to be plus 36. Oh, I didn't have to multiply through by 2. I'm like, why do I have a factor of 2? I could have just divided by 2. Whatever. So 2, I can just divide by 2. So that's x squared minus 6 root 3x plus 18. And calculator. So we get the same answers. 2.20 or 8.20. Okay, 34. In a triangle ABC, ABC, A is 35. BC is 4, AC is 6.5. Find possible values of B and corresponding values of AB. Okay. All right. So we need to do sine rule. 4 over sine 35 equals 6.5 over sine B. So we're going to have 35 and 35. And then B is here and C is going to be here. So we get 68.8. And when we do 180 minus that, we get 111.2. And then, of course, our triangles have to add up to 180. So this one is 76.2. And this one, 1 sec. is 33.8. So that's our values of b, and now we want ab. So we're going to have x over sine 76.2 equals 4 over sine 35, or we're going to have x over sine 76.2 equals, no, not 76.2, sorry, 33.8 equals 4 over sine 35. So for this one we get 6.77, and for this one we get 3.88. All right, for 35 we've got ABC, and we've got AB's 8, BC 6, BAC is 20. Find the smallest possible area of ABC. So we have to find this one out in order to find that one out. So we've got 6 over sine 20 equals 8 over sine C. So we have 20 and 20 for sure. And then this is going to be angle C, and this is angle B. So you get C is either 27.1 or 180 minus that is 152.9. And then we have 180 minus 20 minus 27.1, which is 132.9. And we've got 180 minus 20 minus 152.9, which is 7.13. Okay. And then we will have 1/2 AB sine 132.9, or 1/2 AB sine 7.13. So we have 17.6 here, or 2.98 here. So this is the smallest possible area. All right, for 36, we have ABC. This is 31. This is 3, and this is 5. And we want possible lengths of AB. So we have to find this out first, or let's just use the cosine rule. It's going quicker. So this is little c, this is big C. So we've got 3 squared equals interchangeable x squared plus 5 squared minus 2x5 cosine 31. Okay, so 9x squared 25 minus 10x cosine 31. I don't know if it's going quicker. You have to put this in y1 and this in y2 and find the intersection. So when you do that, you get x is 2.75, or x is 5.82. All right, for 37, we've got triangle ABC and BAC. This is 37.8. AB is 8.75, and BC is 6. Find AC. So we're going to have 6 over sine 37.8. Oh, wait, no. We are going to use, because we want a side length here, so we're going to use cosine. So if this is C and this is C, so we're going to have 6 squared equals 8.75 squared plus x squared minus 2 times 8.75 times x cosine 37.8. So I did this one in NSolve, and I get 4.22. All right, 38, the diagram shows a vertical pole which is supported by two wires fixed at A and B. Find the height of the pole. And we have B to Q is 40. So if we use this back triangle here, we have SOHCAHTOA. So we have opposite and adjacent. So we have tangent 36 equals x over 40. So x is 29.1 meters. And then B, the distance between A and B. Okay. So we have, I think 70 is talking about that bottom angle. So I think if we're using this triangle down here, like this is 70, this is 30. So this would be 80. Oh wait, it says it. I see. BAQ, yeah. Okay. Yeah, so this is 80 here. And we have this is 40, so we use sine rule. So 40 over sine 70 equals x over sine 80. And then you can use n solve. All right, a ship leaves port A on a bearing of 30. So counterclockwise with the north. It sails a distance of 25 to point B. At point B, it goes 100 degrees. It sails a distance of 40 to C. A second ship leaves A and sails directly to C. Okay, so we've got this. Find the distance it will travel. And find the bearing of the course taken by the second ship. So that means we will want that whole thing. Okay, so if that's 30, this whole thing here is 150 because it's two parallel lines are supplementary. They add to 180. So if we've got 100 and 150, that's 250. So this bit is going to be 110. And we just use cosine rule. So we have x squared equals 25 squared plus 40 squared minus 2 times 25 times 40 cosine 110. So you get x is 53.9. So then we can have cosine rule. So we use the unrounded, sine rule. So the unrounded thing we just found over sine 110 equals 40 over sine y, with this being y. So you get y is 44.2, and to that you need to add the 30 to get that bearing from the north, so 74.2 degrees. All right, in a triangle we've got all this. Show BD is equal to that, okay? So we've got BC is A, AC is B, and AB is C. And it's perpendicular. So if we have, so we need to use this. So this is sine of A equals opposite x, which is BD, over hypotenuse. So x is C sine A. For B, show CD. Okay, so we'll say this is y from here to here. And we want with cosine A. So they want this because W is equal, so actually cosine A, because that's what they're using, is equal to adjacent over hypotenuse in that small triangle. So we have B minus W equals Y. I have a cough drop, sorry. So if we solve for W here, W is equal to C cosine A. So we have B minus W, C cosine A, is equal to Y, which is the CD. okay? Hence, using Pythagoras' theorem in the triangle BCD, so that's smaller right triangle, prove cosine rule for triangle ABC. So we're going to have in that triangle x squared plus y squared equals a squared. So we've got x is this, so c sine a, all of that squared, plus y, which is b minus c cosine a squared, equals a squared. So we'll deal with that in a second. All right, so this is going to be c squared sine squared a plus b squared minus 2bc cosine a plus c squared cosine squared a. So now I'm going to do b squared minus 2bc cosine a. And then I'm going to take out a c squared from this and this. Okay, and now that's equal to 1. Sine squared plus cosine squared is 1. So we're going to have b squared plus c squared minus 2bc cosine a, and that's equal to a squared, what we started with.